Alright, today we're going to do a couple of things. We're going to practice finding some domains and range from a graph, and we're going to work on something called inverse relations. So, we defined a relation as a group of ordered pairs. A relation may be a function. So if we had relation A defined by the order pair -3, 2, -2, 2, -1, 3, and 3, 3. We can determine if this relation is a function by looking at its x terms. -3, -2, -1, 3. There are no repeating x terms, so this is a function. Let's express this as a table mapping in a graph. List its domain, list its range, and then find the inverse of this. So as a table, this would be -3, 2, x, y, -2, 2, -1, 3, 3, 3. As a mapping, x, y, list the domain, -3, -2, -1, 3. And then we have range members of only 2 and 3. -3 turns into 2. -2 also turns into 2. -1 turns into 3. 3 also turns into 3. This is a type of relation called a many-to-one relation. If we want to express this as a graph, we would simply just plot these ordered pairs. And I'm going to sketch it. -3, 2, -2, 2, -1, 3, and 3, 3. So we can see that this is a function by the vertical line test. It passes the vertical line test because I cannot draw a vertical line through the graph and pass it more than once. An inverse relation simply means to switch x and y. So if we want to find the inverse of A, this little -1 means inverse of A. That would be not -3, 2, 2, 3. Sorry, 2, -3. Not -2, 2, 2, -2. All I'm doing is going to each ordered pair and switching all of the x and y values. 3, -1, and 3, 3. So if I want to express this as a mapping, I'm not going to go through the table in the graph, but if I want to express this as a mapping, now my domain members are my old range members, and my old domain members are now my new range members. Okay, so if I look at my ordered pairs here, 2 becomes -3. 2 becomes -2. 3 becomes -1. And 3 also becomes 3. So now, if you look back here, the original relation A, not A inverse, A is a function. There are no repeating x terms. This is a many-to-one function. The inverse, however, is not a function because now we have repeating x terms. So this would be a one-to-many relation. There's a special type of function that's called a one-to-one function. A one-to-one function is first and foremost a function, so no repeating x terms. But not only is it a function, it's a special type of function in which there are also no repeating y terms. Which means if I find the inverse of it, the inverse will also be a function. For example, let's say we have relation A, and let's call it 0, 1, 1, 2, and 2, 3. Relation A is a function because there are no repeating x terms. 0, 1, 2. It's also a one-to-one function because there are no repeating y terms. 1, 2, 3. Let's express A as a mapping, and then we'll find A inverse and express that as a mapping to show why they call it a one-to-one function. So the mapping of A, let's list our domain members. 0, 1, 2. List our range members. 1, 2, 3. 0 becomes 1. If our input is 1, our output is 2. If our input is 2, our output is 3. Now A inverse, let's just switch the x and y. 1, 0. 2, 1. And 3, 2. So if you note, A is a function because there are no repeating x terms. A inverse is a function because it has no repeating x terms. Therefore, A is a one-to-one function because its inverse is also a function. So the mapping of A inverse would look like this. Our range became our domain, and our domain became our range. And this is why they call it a one-to-one function, because each element in the domain goes to one element in the range, and each element in the range goes to one element in the domain. One term is going to one term. One term is going to one term. That is why they call it a one-to-one function. You could determine if it's one-to-one simply from looking at the initial relation, A. If there are no repeating x, 0, 1, 2, it's a function. Good. Now we could see if it's a one-to-one function. It cannot be a one-to-one function if it's not a function, first and foremost. Alright, so now I just want to review some finding domains and range from a graph. Here are some graphs. To find the domain and a range, you're looking for all the possible x values and all the possible y values. So the domain in this case, what you have to think is domain is x values. So we're working left and right. How far left does this reach? Well, this arrow means it's going up forever. It may take a really long time to reach all the way over here, but it'll get there. So the arrow is going up forever, so the domain is all reals. The range? Now we're talking about the y values. So how far up and down does it go? How far down does it go? Forever. That's what that arrow means right there. How far up does it go? Forever. That's what that arrow means. So the range is all reals. Domain and range of this. Well, that arrow's going off on an angle there. So it's going to reach all the way to the left eventually. It really may take a long time to get there, but that's going all the way left. It's going all the way right. Again, it may take a while to get there, but that is angled, and that arrow means it's going forever. So the domain is all reals. The range, however, how far down does it reach? Well, it doesn't go past this line right there. So that's the bottom of the range. The top, going up forever. That's what those arrows mean. Stops here, goes all the way up. So this is the minimum value of our range. So here and up is our range. So we have to count how many boxes we're down. -1, -2, -3. So the range is y is greater than or equal to -3. Yeah, it can be -3. It reaches that line, just nothing below it. In this case, our domain, we're talking about left and right here. How far left does this go? Well, right there is the furthest it goes. So this is the minimum member of our domain, from that line all the way to the right. And that is -1, -2. So x is greater than or equal to -2. Now we'll talk about the range. The lowest the graph reaches is the x-axis. The highest it reaches forever, because that is angled, so that's going to go all the way up. So the range, y is greater than or equal to, well, that's 0, 1, 0. Y is greater than or equal to 0. In this case, our domain, the furthest to the left it reaches is right here. The furthest right it reaches right here. So x is between these two values. Put an x between. Furthest left, -1, -2, -3. Furthest right, 1, 2, 3. And this says x is between -3 and 3. Compound inequality, just like the quadratic inequalities. The range, now we're talking about top and bottom. The lowest it can reach is right here. Highest it can reach is right there. So the lowest it can be is -1, -2, -3, less than or equal to y, less than or equal to 1, 2, 3. Now this is an example where there's a hole in the graph. So the domain here, let's take a look. The furthest to the left it's going to reach, well, that arrow, it's going on forever. It's going on an angle. It may take a long time to get over here, but it'll get there eventually. There's no hole in the x values. Crosses here, crosses here, crosses here, up there, crosses here, crosses here. Yeah, so all reals. There's no hole in an x direction. The hole is in the y direction, so that's where we're going to account for it in our range. Our range, well, this is y equals 1 and down. So y is less than or equal to 1, or 1, 2, 3, and up. Y is greater than or equal to 3. So anything between 1 and 3, there is no range value for it. There's no output value. Domain here. Now we're talking about x values, so we're working left and right here for the domain. 1, 2 is the maximum domain member, and less. So we can say x is less than or equal to 2. The range, I'm talking about up and down. How far down does it go? Well, that's angled a little bit. It's going to go all the way down. How far up does it go? That's angled. It's going all the way up there forever. So the range is all reals. Just a little practice finding domain and range from a graph.